All right, everyone. Welcome back. I may or may not have mentioned I've got some craziness going on right now, so it's really hard to stay on top of everything. I know that y'all can sympathize. I know y'all feel like y'all have got a lot of craziness going on with full-time jobs and full-time course loads and everything. So I know that we all understand that side of things. So this is going to be another day. We're just going to keep this lecture a little shorter, and I definitely lean towards keeping this class shorter, as the 154 versus this. Just given the nature of everything, we don't have as many assignments to get through. We don't have as homework to actually get through besides just for that attendance slash participation side of things. This is just extra time to catch up on topics, and we'll definitely handle everything that we need to learn today. We just won't do as many examples as I might have originally planned. But again, we'll still cover everything that you need, and the homeworks always have those question helps with the view an example or guided solutions kind of thing, or view an example or help me solve this. That's the two phrases I was looking for. All right, so we're gonna go ahead and begin. Per usual, I'll be in the chat if you have any questions. Like I said, this is only gonna be like a 30, 40-minute class, so we'll get an easy Wednesday today. All right.
To be pulling from the week 4 my math lab homework assignments in the MDE 54 file today. I went ahead straight to number 3. The first 2 problems are literally the same as this one, and quite literally the same as what we were working on last time, where we've got equivalent fractions getting us used to the idea of getting an LCD. So if we wanted to add or subtract fractions. All right, so find the missing numerator so the fractions will be equal. First, I got to do this. There we go, much better. So we got 2 over 11 first. There we go. 2 over 11, 7. So the idea I said last time was you take the denominators and you divide them. 77 divided by 11 would be 7. And then you take that result, that's 7, and you multiply it by the top number, the 2. 7 times 2 is 14, so 14 should be our answer. And that's it. So what we said is 2 11ths is the same as 14 over 77. And remember, if you don't trust these, you can reduce your the right-hand side, and you should get the left-hand side. Now, if the left-hand side was reducible, because that's possible, that means you'd have to reduce both of them to confirm that they're the same thing. Now, I definitely wanted to do this one because the first fraction, the one on the left, does not have a denominator written. So you need to remember that a whole number, I definitely hit blue, you saw that, 8 is the same thing as 8 over 1. That's very important for this because you have to be able to see the denominator of the 1. So we're saying 8 over 1 is equal to what over 5? So we take the denominators and divide them. 5 divided by 1 is 5. And then we take that number and we multiply it by the original top. 5 times 8 is 40, and that should be our new numerator. I am going to be going a little quicker through these because of the short time. Remember that YouTube has a little, it looks like a wheel, and that's your settings wheel, and you can slow down to 50 or 75% if I am going too fast. One more like this, 4/7 is what over 49? Just gonna keep switching colors back and forth. So you say 49, I clicked it again. Technology, am I right? 49 divided by 7 is 7. Then you take that number, just a coincidence they were the same, and you multiply by the top. 7 times 4 is 28. You're going to need to do these dozens and dozens and dozens of times until you can do them on your own, without assistance, without practice, and then 3 months later you can still do them. All right, so that's enough of those. All right, during the students spent 11 hours studying mathematics at home. During the last 5 days, a student spent 11 hours. This student sounds like they were in both MDE 54 and Math 154. because you're supposed to be spending 6 hours a week for every 3 credit hours. That's 6 hours, I mean studying, homework, whatever. So if you're taking 6 credits of math between 54 and 154, that means you should be studying, homework, whatever, 12 hours a week. So the student's on a good pace. During the last almost week, they studied 11 hours. So in those other 2 days, they can get their 1 more hour in. And remember, that's in addition to class time. Don't forget that. On average, excuse me, on average, how much time is this per day? So average means in general you're adding up a bunch of different things and dividing by the number of things, but this is a little different because they're giving you a total amount over a span of time. It's not a bunch of different individual amounts. So instead, the basic idea, especially since they say per day, is to divide these. So I've given a couple of hints for the past 2 classes in Math 154. The word per means the next thing is a denominator. So because they see day, that means anything that's a value of days would be a bottom. So they're saying how much time the student spent on average, how much time per day. So this is us using our words. We need to do time over days because that's time per day. Time, top, days, bottom. How do I know that? The word per. Time came before it, top. Days came after it, bottom. So all we're doing is just dividing the 11 hours. And notice I'm using my units in this. This is going to be a common theme in the Math 154 class coming up, especially once we hit chapter 3, divided by the number of days, which is 5 days. And then we can pull up a calculator if we like, since they say to type an integer or simplified fraction. I'm going to do this wrong probably, intentionally. That's a big calculator. All right, so we can just do 11 divided by 5. And let's see if this will give us what we want, 2.2. So if I type 2.2, which is a pretty good answer, it says wrong, although your answer is equal to the correct answer, it is not in the correct form. This is something I've tried to warn you about multiple times. They said to type an integer, which basically means whole number, positive or negative, or a simplified fraction, which means because the answer was a decimal, and sure, in the real world, nobody's going to care that it's a decimal, but here my math lab wants a reduced fraction. So if there's a number that goes into both 11 and 5, then you would divide that out and reduce it. For instance, if this was, say, 12 over 15, 3 goes into both of those. 3 would go into 12 4 times and into 15 5 times, so the answer would be 4/5. But there's no number besides 1 that goes into 11 and 5, so you just type 11 over 5. Now, you might go, hey, Mr. Beckner, how'd you get that fraction bar? You didn't click the fraction bar. I typed 11, then I hit my division key, which looks like a slash on the keyboard. That automatically makes a fraction. It won't work for a mixed number. You'd have to click the mixed number, but that's an alternate way to do it. And we got it right now. So pay attention to the instructions. Write the ratio in simplest form, 21 to 33. So we got 21 over 33, no units, so no words. And 3 goes into both of these. Some people do their work this way. They'll slash and say 3 goes into 21 7 times, 3 goes into 33 11 times, which gives us 7 over 11. Or some people will show their work like this. And they'll say, all right, 3 goes into this one, 3 goes into this one. You have to pick a number that goes into both. And you want to get the biggest number, or you'll have to do this again. And then you still get the same answer of 7/11. I don't care how you get jobs done. I just care that you do them. 7/11, beautiful. Next question. Remember, there is a slow down button in YouTube. Please feel free to use it. 36 to 32. So we got 36 on top of 32. Again, I hit this. Oh, well, doesn't matter. 36 divided by 32. Pay attention. This is how simple mistakes are made. You know what? I'm doing this whole thing in black. 36 to 32. The word to also kind of is like the word per. It means the next thing goes in the bottom. I much prefer the slash method personally. Some people might just not even write anything and go straight to the answer of, I don't know, 2 over 3 if that was it, which it's not. If you can go straight to the answer, that's fine. Let's see, 2 would go into both 36 and 32. So I could divide both of these by 2. 2 will go into 36 18 times. 2 will go into 32 16 times. Spoilers, this is wrong. So I get excited, I reduced it, and I go 18 over 16, and it tells me I'm wrong. Although your answer is correct, it is not in the correct form. They don't always give you exact instructions on, oh, it's right but not right. So you have to figure it out. What else is going on here? Well, both 18 and 16 are divisible by 2. So you got to divide those by 2. That's a 6 in the bottom. That's just an ugly 6. So 2 goes into 18 9 times, 2 goes into 16 8 times. So let's see if 9 eighths will give us the answer. 9/8. Boom, we're good. So alternatively, you could have said 36 over 32. You may recognize that 4 goes into both of these. 4 goes into 36 9 times, and 4 goes into 32 8 times, giving us the answer right out of the gate. So you can reduce these in multiple steps or one step. Sometimes it just depends on which numbers you are looking at, seeking out, and how you do it. But when you reduce, make sure that your answer isn't reducible even more. 70 minutes to 30 minutes, 70 over 30. 10 is going to go into both of those. 10 will go into 70 7 times. 10 will go into 33 times. 7/3 is reduced as much as possible. 7/3, boom, we're good. All right. I'm not going to do any more of those, which is good because there was only one more. Indicate whether the statement is true or false. 2/5. So what they're really saying here, come on, why is it doing that to me today? Technology. I know why now. I just figured out because I'm clicking between one thing and another thing, so it's not registering the color change. Not that you care. 2/5. This is what we're saying. Is it equal to 6 over 20? So there's 2 ways you can do this. One of them is to reduce both sides as much as possible and see if they match. If they do, then it's a true. If they don't, it's a false. Another way is, and this is the only way I'm actually going to show, is to cross multiply and see if the left side is the same as the right side. So we've been doing a whole bunch of proportion solving in regular 154 for the past week and a half, technically, since we missed a class. So being specific, the last 2 classes. But all of those had a variable in one of these spots, and we were doing algebra and solving it. This doesn't have a variable. We're just cross multiplying and seeing if we get the same number. So when we cross multiply, we take the 2 times the 20, and then we'll take the 5 times the 6. And we're saying, are these equal to each other? It's good to write the question mark, but I'm not going to discount you if you don't. 2 times 20 is 40. 5 times 6 is 30. That is a big fat no. That's false. Those are not the same. If you reduce the right-hand side, 2 will go into both of those. You'll end up with 3/10. 3/10 is not 2/5. So that also says false. I'm not going to do a bunch of these. Cross multiply. We will do one where we actually solve in case you just need to see that one more time outside of regular class. So cross multiplying. Take the 8 times the 13. Set it equal to the x times the 2. I prefer to write the 2 first, but it doesn't technically matter. All right. 8 times 13, 10/8 is 80. 3 of them is 24, so that should be 104. And that'll be equal to 2x. Now, as a reminder, it's very simple algebra. If you have 2 times a number, 3 times a number, 5 times a number, if there's only this one step, it's only this one thing to get rid of on the side of the variable. If that's a multiplication, you divide both sides. If it was an addition, you would subtract. If it was a subtraction, you would add. If it was a division, you'd multiply. Remember that addition and subtraction are opposites. Multiplication and division are opposites. And then half of 104 should be 52. So that should be our x. Let's see if it's right. Maybe your teacher led you down the wrong path intentionally. Maybe you didn't. I always like to keep you on your toes. You never know, right? But that's because that's how things work when you're doing stuff. And I know I've made 1 or 2 mistakes on accident. But again, I like that because it proves that everyone's human. Everybody makes mistakes. But we can get the answer, see that it's wrong, and figure out what we did wrong. That's true learning. Doing things wrong and then doing them right. One more of these. 6 over x, let's write it first, equals 2 over 11. Cross multiply, 6 times 11. And then the 2 times the x. Set them equal to each other, which is 66 is equal to 2x again. Divide both sides by 2, and you'll get 33 equals x. I'm not going to do a lot of wrong things today, given the short time. All right, that's another one. Try it out on your own, try it out on your own. We gave you a whole bunch of these to try out on your own. All right, so this is getting into the true nature of proportions, throwing them in word problems, making them much more real world like. The nutrition information on the cereal box says that a third of a cup serving provides 100 calories and 4 grams of dietary fiber. At this rate, how many calories and grams of fiber are in a half cup serving? So this is definitely a more challenging problem because there's actually two different proportions you're kind of setting up here. So a third of a cup provides 100 calories and 4 grams. In fact, let's circle back to this one. Sorry. I want to circle back to that one in the interest of time because that's going to take me about 12 minutes to go through because of the fractions. Sorry about that. The half and the third are going to muddy things up a little bit, and I don't want to take the half of the time remaining for one problem. So circle back to that. Let me make a little note to myself. Silly. Number 18. Stop it. All right. Identify the operation to perform on each side of the following equation to isolate the variable. X plus 5 equals 7. So this is what I was talking about a couple minutes ago. When we have the proportions, when we saw 2 times x, the opposite of multiplication is division, which is why I chose to divide 2 on both sides. Same with the previous example, just coincidental numbers. This one, what we've got is x plus 5 equals 7. And the main idea of algebraic equations is to isolate the variable. You're trying to get this thing by itself. You don't want to see the 5 on the same side. What I like to say is that 5 has got COVID-19 or the flu or the cold or whatever you want to go with, and the x is scared and wants to be isolated from it. So we've got to move the 5 over. But the rules of equations say to move things from side to side means you have to do opposite operations. So because this 5 is being added to the variable, that means what we have to do is subtract 5. And then the other idea is that whatever you do to one side, you do to the other, which would end up giving us x is equal to, the 5 minus 5 cancel, 7 minus 5 is 2. That would be our solution. Now, you might say, well, it doesn't ask me to write x equals 2 anywhere. That's because the instructions weren't to solve it. Just what do? Identify the operation to perform on each side. That's the red ink. We subtracted 5 on both sides. Now, there's something cool about equations. Technically, I can do just about anything I want to on that equation. I can add 3 on both sides. I can multiply by 17. I can divide by pi. I can square both sides. I can square root both sides. Asterisk, kind of, but we don't do that in this class, really. But you don't want to just work randomly and do whatever you want to do. You got to work with purpose. So you got to think about, what am I trying to get rid of? I'm trying to get rid of the plus 5. So I need to do the exact opposite of plus 5, which is minus 5. If that was x minus 5 originally, I'd need to add 5 to both sides to get rid of it. Similar here, x minus 7 is equal to 9. Because we want the variable isolated, we want this by itself. This minus 7 has got to go. Because that's a minus 7, to move it, we add 7 to both sides. So answer A again. You don't believe me? Oh, subtract 7. Let's try it out. Nope. Cool. Then we get in that sum where we actually want to solve it. So we got W minus 14 is equal to 22. So on the side of the variable, this is the thing we want by itself. We need to move the minus 14. To move that, we have to add 14 to both sides. If you don't write things vertically, I don't care. If you write them horizontally, that's fine. If you don't write this at all, if you get the right answer, that's fine. 22 plus 14, well, 2 plus 4 is 6, 2 plus 1 is 3, so 36. I'm going to do this wrong. W equals 36. That's incorrect. Solve it, blah, 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 blah. This actually tells us nothing about what we did wrong. What did I do wrong? Because I've seen students do this. I've definitely seen students do this. I wrote the variable in there, but the variable was already set up for us. So all we really needed to do was write the 36. Cool. More of those. Like I said, I'm trying to get as much done as I can in 30 minutes, more. Actually, we'll do, this one's a little more challenging and it's a decimal, so let's mix it up. X plus 5.1 equals 8. Technically, it's not challenging since you're allowed calculators, in my opinion, but I'm going to do it by hand. So that says plus 5.1. So we subtract 5.1 on both sides. Now, when you add and subtract decimal values, you're supposed to line up the decimal. Now, there's no decimal written in this 8 originally. So the 8 is the whole, the 5 is the whole, which means the 5 goes into the 8, and then a 0.1 obviously goes to the right of that. So here's what you want to do. You want to take that 8, put a decimal in there, and a filler 0. When you're adding and subtracting, you need these decimals lined up, and then you just bring it down, and you subtract like they were whole numbers, 80 minus 51. 0 minus 1 you can't do, so you got to borrow from the 8. That becomes a 7. The 0 becomes a 10. 10 minus 1 is 9. 7 minus 5 is 2. That gives us x is equal to 2.9. Again, this is a skill you should have at this level. I should be able to give you a calculator-less test on this stuff, and everybody gets hundreds in theory. There's another one, but that one already had a decimal, so it's not too bad. Something I brought up at least once before, either in this course or 154, I think in this course, that we have some special phrases when we're setting up, going from sentences to equations or expressions. Phrases like less than means you're going to reverse the order of what you see. So 6 less than n is not 6 minus n, it's actually n minus 6. Again, less than reverses the order of those two things. The word is means equals in equation words, and then 13 means 13. They didn't ask us to solve it, they just asked to set it up. N minus 6 equals 13. Maybe you don't trust me on that less than. Let's try C. 6 minus n. Check. Nope. Note, less than indicates subtraction, but they don't even remind you that they reverse it. So you might, well, that is a subtraction. Well, again, Mr. Beckner reminded you at least multiple times that it reverses it. All right. Oh, then solve. That's what happened. Okay, then solve. We got to pay attention and read instructions. What happens when we rush? There are 9 minutes left. So n minus 6 equals 13. We're trying to get the n by itself, which means the minus 6 is what needs to go away. But we don't just scratch it out like that. Since it says minus 6, we add 6 to both sides. We will not be giving you extremely complex algebraic equations to solve by hand in this course, but you will get simple ones like this. Proportions over and over and over and over and over and over and over. Notice I didn't have to type the n and the equals because it was already there for us. If the variable's on the right side, does that really affect anything? No. 6 equals x minus 8.4. The x is what you're trying to isolate, so you got to get rid of the minus 8.4. We do that by adding on both sides. Add 8.4. You'll want to make that up 6.0 then. Add 8.4. And then we get equals x on the right side. Those cancel. And then 60 plus 84, well, 0 plus 4 is 4. Bring down your decimal. 6 and 8 is 14. All right, give me 10 seconds. Okay. Didn't even need it. 14.4. Sounds good. If you want to check your solutions, you just plug it in. So we got 5 minus x is equal to 2. They say, is 2 a solution? So turn the x into a 2. So we go 5 minus, I'll use red for the substitution, 2. Now what we're saying is this equal to what we originally had on the right-hand side? 2. Well, 5 minus 2 is 3, which is a big fat no. 3 is not 2. Fill in the blank. In the equation 2x equals 6, blank each side of the equation by 2 to isolate the variable. So this is not 2 plus x, this is not 2 minus x, this is 2 times x. The opposite of multiplication is division, so we should be dividing both sides by 2. They only give us 2 options, multiply or divide. If you try multiply, final check, nope, it was wrong, we're supposed to divide. Try again. Literally the same problem, divide, boom, we're good. Be funny if it was wrong, right? This one, identify the operation. So this is x divided by 4. So because what you see is a division, you need to multiply. Do you multiply by 5? Question mark? Question mark? Hint? Inflection in voice? No. Multiply by 4. We have to do it this way. So we had x over 4 is equal to 5. This is what you would do. That 4 is in the bottom. We got to get rid of the 4 in the bottom. So that's why we multiply both sides by 4, because a 4 and a top and a bottom as a product and division all cancel. And then what you end up with is x equals 4 times 5, which is 20. They didn't ask for the answer, but there it is. Or did they? I did not receive credit. Oh, I didn't actually check it, did I? Let's go back. There we go. Divide by 3, you get 11. Multiply by 2, you'll get 22. Divide by 2 and you'll get 2. Multiply both sides by 3 and you'll get 30. Here's an interesting one. 0.3, come on. Black, thank you. 0.3x equals 9. That's a product, so we got to divide, but we got to divide both sides not by 3, but by 0.3. Now, you got calculators, so that's probably going to be how you do this, but as a reminder, what you should understand is that you can't divide by decimals. So this 9 divided by 0.3, what you have to do is make the bottom a whole number by moving its decimal right as many times as you have to, which would be ones in this case. But whatever you do to the bottom, you have to do to the top. It's kind of like an equation, whatever you do to the left, do to the right. So that would be a filler 0, and what you end up with is 90 divided by 3. So 9 divided by 0.3 is the same as 90 divided by 3. It's also the same as 900 divided by 30, 9,000 divided by 300. I can keep moving it as much as I want, but once the bottom's whole, that's all you really got to do. So x is equal to 90 divided by 3, which is 3 will go into 9 3 times, tag the 0 because it's perfect, 30. So that's a nice trick to have. Again, I know you're going to be using calculators more than I like, and that's okay because it's the real world. That's what this class is supposed to be for. The fact that this is written as 1/8 instead of x over 8 doesn't change anything. Multiply both sides by 8 and you'd get 80. Honestly, this problem we're not ready to do yet. I didn't think about, and that's just because this problem is a little further in chapter 2 than where we've gotten in the regular class, so skipping for now. Also skipping, I think that's probably the case for the rest of these for now. These are doable, especially with the multiple choice ones, but I haven't talked about things like inflation in the regular class. Inflation makes things less valuable over time, just FYI. This is a homework question, and yeah, I don't want to do that one because it's also a homework question in 154. Again, all this stuff is stuff we're not ready for, so this is going to end up draining into week 5 as well. I did mention that we'd fall behind at some point, and this is us finally starting to fall behind. Okay, so that'll be it for that for now. So let's go back to in the 3 minutes I have. Week 4, stress management. Remember, lots of questions. First one's a video, so I always go to the second one. Jackie is a freshman in college. She works and studies a lot. Jackie is also pledging a sorority and is required to attend sorority service and fellowship activities. Jackie feels that the most stressful part of college is pressure to drink at off-campus parties. What strategy can Jackie use to lower her stress levels related to this problem? So I think this one's pretty interesting. It's, I guess a social dilemma that Jackie feels the most stressful part of college is pressure to drink at off-campus parties. It's not the stress of tests or studying or going to class or getting somewhere on time or dressing appropriately. It's partying. But, that's how some of us are. So that's facts of life. What strategy can Jackie use to lower her stress levels related to this problem? Drop out of the sorority so she can avoid future parties. I mean, the sorority might have some other good things besides just off-campus parties. Plan to use over-the-counter health aids and exercise after the next party. I don't really think that's going to help stress before. They're just stressing over a hangover or something. Plan whether and to what extent she will drink before attending a party. I mean, you could include 0 or very little in that. Plan to get at least 7 hours of sleep after the next party. Again, aftermath, probably not the important side. A and C seem like the most possible, but like I said, sororities and fraternities do lots of other good things besides just party, whether you've heard otherwise or not. So plan whether and to what extent she will drink before attending the party. You don't have to succumb to peer pressure, all that stuff. What life skill is closely related to stress management? Money management, social choices, time management, career choices. Oh man, that seems like a lot of those might be possible at first glance, I think. What life skill is closely related to stress management? Stress management. I feel like money management and time management are probably pretty close, but career choices could also envelop money management and time management. Social choices, they just talked about the last question, stress management on a social choice, but it's not the only type of stress that we can see. Career choice. Stress management is closely related to time management. Well, wow, they just pretty much gave you the blatant answer that I was trying to avoid. Money management, I honestly think, is pretty stressful to a lot of people, especially since I would say 9 out of 10 Americans do not know how to manage their money. But time, I mean, no matter how much money you have, you decide to make, you can't affect the amount of time you have in total, so you have to manage what you're given well. You can find a way to make more money. You can't find a way to make more time. And that's got to be time, pun intended. That's all the time I have, unfortunately. Like